Hey, hi everybody, Dr. Marty here, and today I'm going to be working through our first set of notes for Chapter 2. This is still a review from last year, but today we're going to be talking about solving equations. Solving equations, we're going to be solving equations that have a variable in them. This is the basics of algebra, or pre-algebra. And to start off, our goal in solving equations is to solve for the variable, okay? To solve for the variable. Remember, our variable from our last set of notes is some type of symbol that represents a changing quantity and potentially unknown or changing quantity. Okay, it's something that's not fixed. So that's generally represented as a letter like X or A. And so if we see an equation that has a variable, we're often asked to solve it. To solve it means to isolate the variable on one side, to isolate it down so you only have the variable on one side. The other side is going to be our answer. When you're doing it, there's really just one rule you have to worry about, which is whatever you do to one side, you must do to the other. Anything you do to one side, you have to do to the other. If you add to one side, you got to add to the other. If you subtract to one side, you got to subtract to the other. If you tell a joke to one side, you got to tell a joke to the other, so on and so forth. Okay, so we're going to start off with example 1. This is pretty basic. Okay, these are pretty straightforward equations. So this one says 2x plus 3 equals 15. Right? So we're trying to solve for the variable or isolate this x on one side of the equation. So we're going to get the x only on the left. So the first thing we have to do is we have 2 times x plus 3 equals 15. Well, I see this plus 3. Now I want to move that plus 3 so it's no longer on this side of the equation. I want to get rid of it from this side of the equation. To get rid of it over here, I have to subtract 3, right? If I subtract 3, it'll no longer be on this side. But if I'm going to do that to one side of the equation, I have to do it to the other. So I'm going to subtract 3 over here. And do that, I'm left with only 2x over here. And now that's going to equal 15 minus 3, which is 12. All right, we're getting closer. Now we have 2x equals 12. How can we isolate the x? Well, if we have 2 times x, if we divide by 2, these 2's will cancel out. Well, guess what? If we're going to divide by 2 on one side, we got to divide by 2 on the other side because we are very giving and we always do things to both sides. So now we're left with x over here. And then we have 12 divided by 2, which equals 6. We've now isolated the variable or solved for the variable, and we get x equals 6. Pretty simple, right? Let's look at example 2. Example 2, okay? Example 2 says 1/2 a plus 5 equals 18. Very similar. 1/2 a plus 5 equals 18. First thing we're going to do is subtract 5 on both sides. Right? We do it to one side, we do it to the other. We get 1/2 a equals 13. Right? Now, we have 1/2 a. Well, what we need to do is we need to get rid of this 1/2, we have to multiply by 2 over here, right? Times 2. But to do that, on this side, we got to do it on this side too, so we're going to multiply by 2 over here. These 2's cancel, we're left with a on this side. 2 times 13 is 26. We've solved for a. All right? Let's move on to example 3. Example 3. Remember, we're just solving for the variable. We're making sure if we do something on one side, we do it on the other. Here we have x minus 7 divided by 3 equals negative 12. Note the negative number, okay? So because this whole x minus 7 is divided by 3, this whole quantity is divided by 3, the first thing we have to do is get rid of this 3. To do that, we're going to multiply by 3 on this side. But if we multiply by 3 on this side, we have to multiply by 3 on that side. Remember, we're being fair and multiplying or dividing or adding or subtracting on both sides. These 3's cancel out. We're left with x minus 7 on the left. Then we multiply. 3 times negative 12 is negative 36. Here we have x minus 7. We're going to add 7 to this side. To do that, we've got to add 7 to this side. We get x here. Here we get negative 36 plus 7, or negative 29, which is our answer. Okay. Finally, example 4. 4x plus 8 equals 3x minus 2. Now this one's a little bit different because now all of a sudden we have an x on this side and an x on this side. So you got to decide what you're going to work on first. Okay. Let's start by isolating our 4x over here. So I'm going to subtract 8 on this side to get rid of this 8. To do that, I've got to subtract 8 over here. So I've only got 4x left here. On this side, I've got that 3x still, But now I've got negative 2 minus 8. Negative 2 minus 8 is negative 10. Well, now I want to get it so the x is only on one side of the equation. Well, I've got 4x here and 3x here. So I'm going to get rid of the x over here. Get rid of the x over here. To do that, I'm going to subtract 3x. Well, guess what? If we subtract 3x there, we've got to subtract 3x here. We're left with x equals negative 10. 4x minus 3x leaves 1x. That equals negative 10. Pretty straightforward. Okay? Let's do 2 more examples that get just a little bit more complicated. And then we'll be done with these notes. So here's example 5. Example 5 says 5 times the quantity 2m plus 3, this is a quantity, equals 4m minus 7. 4m minus 7. Okay? Now, there are a couple different ways you could approach this problem. But the first thing that I see is this 5 needs to be distributed. Okay? We could try to divide by 5, but because 4 and 7 aren't going to divide by 5 equally, we're going to get some really crazy fractions if we go that route. So what I'm going to start by doing is I'm going to distribute this 5. To distribute the 5, I'm going to use one of these little guys, right? So 5 times 2m, all right? And I'll write it out just to show you, although you don't need to write this out. You can just do it, right? Plus 5 times 3 equals 4m minus 7. So now I'm going to actually multiply these. 5 times 2m is 10m, plus 3 times 5 is 15, equals 4m minus 7. Like I said, you don't need to write this out. I just wanted to do it to show you what I was doing. Okay? So now let's solve for m, right? We're trying to isolate m on one side. I'm going to start by getting rid of this 15. To do that, I'm going to subtract 15. Remember, I've got to do it on both sides. I'm left with 10m over here equals 4m. And then negative 7 minus 15 is negative 22. Negative 22. Okay? So now I've got 10m equals 4m minus 22. All right? 4m minus 22. Sorry about that. Now I'm going to subtract this 4m to get all of my m's over on the left. So I'm going to subtract 4m on both sides. I'm left with 6m equals negative 22. Don't lose that negative. It's 4m minus 22, so it's still a negative. Now to solve for m, I'm going to divide by 6 on both sides. These 6 cancels. I'm left with m equals negative 22 over 6. Now, this is not fully simplified. Not fully simplified. Why? Because both 22 and 6 have a common factor. That common factor is 2. 22 is 2 times 11. 6 is 2 times 3. So I can further simplify this. If I divide both the top, the numerator, and the bottom, the denominator, by 2, I get negative 11 thirds. Okay? And then our final one that we're going to do is 5p plus 7 plus 2p equals 3p plus 4 minus p. Now, if we see something like this, the first thing we want to do is combine like terms. Combine like terms on one side of the equation. So here, we've got 5p plus 7 plus 2p. I'm just going to rearrange this. I'm just going to rearrange this with like terms. So I've got 5p plus 2p, right, plus 7. I'm just using those parentheses to show you that these are like terms, equals 3p minus p plus 4. Okay? 5p plus 2p is 7p plus 7 equals 3p minus p is 2p plus 4. Now we can start solving. Let's subtract 7 on both sides. What are we left with? 7p equals 2p. 4 minus 7, positive 4 minus 7 is negative 3. Let's subtract 2p from both sides. 5p equals negative 3. Divide by 5, these cancel and leave us with p. Divide by 5, and p equals negative 3 over 5. Note the negative sign. You've got to remember that you keep the negative sign. Okay? So with equations, we're trying to solve for a variable. All we have to remember is if we're trying to clear something from one side, to isolate a variable on one side, we have to do the same thing to the other side. I hope that that's helpful, and I will see you next time.